Today, in this video, I'm going to derive the third equation of motion using the calculus method. The equation is v square minus u square equals to 2as, where v is final velocity, u is initial velocity, a is the acceleration, and s is the distance traveled by the body. Now, for starting this derivation, the first step that you have to use is the formula of acceleration in calculus, that is dv by dt. This is the formula, you know this formula, that acceleration is dv by dt, rate change of velocity, dv by dt. The next step is we have to multiply this equation and divide this equation by ds. So what you have to do, you have to multiply and divide by ds. So a is equal to dv by ds multiplied by ds by dt. So what I have done, I have just multiplied and divided by ds. Now ds by dt is formula of velocity, right? So a is equal to v dv by ds. Now what has happened here? Dv by ds as it is, ds by dt is formula of velocity. Now cross multiply, you get a ds is equal to v dv. Now to find the real equation, you have to integrate and put the limits. Here you have to put limits of velocity. So velocity ranges from u to v. So the lower limit would be u and upper limit would be v. Similarly, distance ds ranges from 0, starting from initial point, to s, that is total distance. Now if you integrate this, what you get, a is constant, integration of ds is s only. Put the limits 0 and s. Integration of v dv, that would be v square by 2. Initial to final, u to v. Put the limits, you get a, s minus 0 is s only, and if you put the value over here, you get v square by 2 minus u square by 2. V square by 2 minus u square by 2. Take the LCM, and this 2 can be shifted that side, and you get the equation, that is 2as is equal to v square minus u square. And this is the way you can derive third equation of motion using the calculus method.